So before this, I hope you are familiar with the trigonometry functions. Am I right?
Hmm.
Basic trigonometry. This time we will be concerned about the measurement of the angles like radian, degree, when they are going to be positive, negative.
Yeah.
These are the contents of the topic, chapter number 4, trigonometry. So consider the figure. So sometime we need to find out what is going to be the angle there. Okay. So in angle, you may have seen these type of figures earlier also. So there are two rays. This is ray 1, this is ray 2. Let me just give the name. This is going to be A. You can consider this is B, this is C. So we are talking about ray BA, we're talking about ray BC. So whatever the inclination, so we will be measuring this in terms of the angle there. So there is one side you call it initial side, there is another side you call terminal side, and this you already know. I'm not interested there. The point
Hmm.
here is there are two ways of measuring the angles. One, you can measure like in this direction. This direction is called anti-clockwise. Anti-clockwise measurement. Other way, you can tell me that you can go around this direction. So there are two ways of measuring an angle. Am I right?
Hmm.
So whenever we measure the angle anti-clockwise, the angle is going to be positive angle. And whenever you are measuring opposite side, we are calling it negative angle.
Hmm.
Can you please help me again? What is the positive angle? Whenever we measure
We're
the angle
going,
in
whenever you're measuring the angle anti-clockwise, it's positive, and clockwise would be negative.
perfectly okay. So look at the figure, please. I hope the figure is self-explanatory for you. So there are two
Hmm.
angles. When you go this direction, this is going to be positive. When you go opposite direction, it is going to be negative there. Okay. There is a wording called co-terminal angles. Look at the statement, please. If you look at the figure there, it is clearly an observation. There is one initial line, there is one terminal line. You're measuring the angle in anti-clockwise, clockwise. One is going to be positive angle, one is going to be negative angle. What is the relation between them? The answer is they are going to be co-terminal. Okay,
Okay.
they are having the same terminal. So this is co-terminal. So if you talk about this angle, they are also co-terminal for you. And so these two angles are going to be co-terminal, having the same terminal side. Am I right?
Yeah.
Perfectly clear. Next, measurement in radian. This is going to be something very important, and we are going to focus on this. Okay, let me just try to help you there. Try to consider the figure. Okay, if you look at the figure carefully, so just suppose it is a unit circle. I'm considering always, most of the time, whenever I will be considering the unit circle. Okay,
Okay.
unit circle stands for unit circle stands for the radius is going to be 1. For the
One.
moment,
Okay.
it is not 1, but if I just tell you that it is in unit circle, by default the radius is going to be 1. So
Okay.
this is radius r, this is radius r. So this s is denoting the
Okay.
arc length. So in a moment, just for this purpose, consider this is r. So this arc will certainly will have an angle at the center. This angle is denoted by theta. What is
Okay.
going to be the relation between these three? Remember?
They're they're the
Yes,
same.
they are the same. Okay, so basically, this is the situation. Let me tell you once more. And yes, you consider this angle is theta. This radius is r, this radius r, and this radius is going to be r there. So always remember all these three things are going to be r. What is this side? It is going to be arc length. So whatever the length, so whatever the measure of angle, okay, at the center by the arc of length equal to radius, this angle is going to be over 1 radian. This is how we define the radian angle. Let me tell you once more.
Okay.
Okay, so let me just see the definition actually. Yes, again. So I'm going to discuss about the radian. So what is a radian? Let me just talk about what is equal to 1 radian. So 1 radian is going to be equal to the angle at the center by the arc of the length r. What is r? R is the radius there. So this is 1 radian. Let us just get a definition of the radian when the arc is not equal to the radius. This is important and this relation should be useful. Theta is going to be in radian whenever there is an arc of length s, okay, and the angle it is inserting at the center is going to be theta. The radius is going to be r. So what is the angle? This is going to be theta equals s upon r. You will call it like the radian. 1 radian is the measure of central angle theta that intercepts an arc s equal to the length of the radius. 1 radian, I discussed about you what is 1 radian. And whenever this arc is of length s, arbitrary length, what is going to be the theta? Theta is going to be s upon r. Remember in the numerator you have s is going to be real number, r is also a real number. So real number upon real number, it cannot be degree, what we used to have like a measure. So we have another measurement, another like the unit, we call it radian there. From
Okay.
now onwards, whenever you see trigonometric function and where I have not explicitly told you it is going to be degree, by default it is going to be radian there.
Okay.
Okay. So there is one question basically. So just suppose it is a complete circle. You have center there. You started from A. Okay, and then after you just moved along this curve completely and you ended at B. So basically there is an arc, say S, and this arc is going to be 2 pi r. It will certainly have a central angle. So what is the central angle? Central angle will be like this. Am I right?
Mm-hmm. Yeah.
The question is what is going to be the theta there? The answer is going to be theta is going to be what? S upon r. What is S there? S is going to be how much? Help me. 2 pi
360.
r. 2 pi r. S is
Oh,
the
yeah, right.
arc length. Divide
Mm-hmm.
by r there. This is going to be 2 pi. So basically, when you have a complete circle, it will have a central angle equal to 2 pi. Any doubt?
No.
Okay, perfectly okay. So this theta equals 2 pi, whatever we have learned, it is approximately equals to 6.28. Why it should be approximately only?
Because pi is like never ending.
Yes, because pi is an irrational number. You are absolutely right there. Okay. One observation. It will come later on, but I'm just discussing about this. We already have two measurement of angles like degree and radian. So whenever there is a circle like this, and what is going to the central angle? In radian, I just learned it is 2 pi, but it is also known to me that it is 360 degree. Do you agree?
Yeah.
So angle, central angle, I'm talking about the central angle. So in a way, if you wish to just equate two things, you may consider, and you will consider actually for the conversion purpose that 2 pi is going to be 360 degree. Will be helpful for the conversion. So
Okay.
whenever I need to convert an angle into degree and degree into angle, this is how I will do. Or you can say that my pi is going to 180 degree. So if I talk about what is going to be pi by 2, it is equivalent to 90 degrees. Okay, so this is how I will be able to convert in degree to radian, radian to degree there. We will be having questions based on the same maybe soon.
Okay.
So now, like you may know, just consider the figure. I discussed about 1 radian. So what is 1 radian? When the arc length is going to be r. When the arc length is going to be r, whatever the central angle based on this arc, this is going to 1 radian.
Okay. Yeah.
So this is going to 1 radian. From here, you again have 1 radian, again 1 radian, 1 radian, 1 radian, 1 radian. Total up to this point, there are 6 radian plus some additional angle. This additional is because that 6.28 is the expression there approximately.
Mm-hmm.
So it cannot be complete. But yes, like I told you, when you complete half revolution, complete half revolution, that means you are at this point. You are at this point, just opposite to from where you started. So it is going to pi radian 1/4. That means you are at 90 degree. Then that means pi by 2. Let me just mark this point. These are going to be important. When what is the angle here? Angle is 0. What is the angle at this point? It is 1/4 of the total. What is the measurement? Oh, sorry, I made it is pi by 2. What is the measurement of angle here? It is just opposite. It is half of the total. Total was 2 pi. Up to this point, this is going to be 3 pi by 2. And when you go back, it is going to be 2 pi also. So always assume this circle. Any
Okay.
doubt here?
No.
Perfectly okay. So next important thing. Next is going to be the quadrants basically. Quadrants
Okay.
you already know. When we were dealing, we had you maybe dealt about the quadrant in degree also. So from 0 to 360 degree, we are dividing into 4 quadrants. What are the quadrants? One is going to from 0 to 90 degree. So 0 to 90 degrees. Remember, I'm not including the axis. Angle is in between 0 to pi by 2. Do not include the axis.
Okay.
Quadrant 2 stands for 90 to 180 degree. Whatever the angle in between 90 to 180 degree, it will be in second quadrant. Quadrant 3 will be whenever you have angles between 180 to 35 or 270 degree. It is in quadrant 3. And when you have back 360 degree to 70 degree, it is going to be in the fourth quadrant. Because we are discussing, we will be having terms in terms of radians. So 0 to pi by 2 first quadrant, pi by 2 to pi second quadrant, pi to 3 pi by 2 third quadrant, and up to so on. Any doubt there?
No.
Perfectly okay. One more thing I wish to tell you. Just suppose there is an angle theta equals pi by 6. Consider the situation. Can you please help me in which angle it will, in which quadrant it is going to be? And you
It's
have,
gonna
it's gonna be
in quadrant 1.
perfectly okay. I have no issues with it. There is another angle pi by 6 plus 2 and pi, where it will fall.
Plus 2. Quadrant
Just
1.
consider n to be 1. Perfectly okay. So the situation will be like this. Uh, there is a angle pi by 6. So when n is going to be say 1 there, you will have a complete round and you will be coming at this point angle. This is going to be over 2 and not and that 2 pi plus pi by 6. Okay, it is going to be, let me just start from the beginning. Sorry, let me start from the beginning. When you start from the beginning, that is the initial line, and take complete one revolution, and then have a co-terminal. The same, then the co-terminal angle is going to be The angle you will have, this is 2 pi by 6. When you take
Okay.
two rounds, starting from the beginning, you are taking one round, then after another round, so this time it is going to be over 2n pi. Sorry, n is going to be 2 there. That is 4 pi plus pi by 6. So ultimately, what you're going to have, you're going to have coterminal angles, or they are going
Okay.
to be same. So whenever there is a 2n pi, okay, so 2n pi will actually, whatever 2n pi plus theta, these two angles are going to be coterminal always. So we may consider 2n pi is going to be like 0 in terms of measurement because they will be giving you the same angle. Any doubt there?
Okay. No.
Perfectly okay. So here there is a simple observation you need to find out is sketching the angles there. So for the positive angle 30 pi by 6, subtract 2 pi and to obtain a coterminal angle. Perfectly okay. So 13 pi by 6. Subtract 2 pi there. What you will have? Is it going to be pi by 6 only? Am I
Yeah.
right?
Yeah.
Also observe this 13 pi by 6, it is nothing but 2 pi plus pi by 6. And I told you 2 pi plus pi by 6 and pi by 6, they are going to be coterminal there. It is the same validation.
Mhm.
2 pi is nothing but 0 for you. So if you want to sketch this, this is how you will sketch. I hope it is the same thing and we have discussed a similar example maybe in the previous, maybe on the previous slide. Am I right?
Yeah.
So forget about that. For the positive angle 3 pi by 4, subtract 2 pi to obtain a coterminal angle. So let me just help you in drawing this angle. What is pi by 4? Pi by 4 is going to be 45 degree. 3 pi by 4 is going to be 135 degree. So I'm expecting that if you ask me, this is around 135 degree, which is equivalent to 3 pi by 4. You have
Yeah.
initial, you have the terminal line, and this is angle 3 pi by 4. When you measure it anti-clockwise, this is the angle. Okay.
Mhm.
When you subtract it from 2 pi, so 3 pi by 4 minus 2 pi is going to be 4 to the 8 is going to be negative 5 pi by 4. Am I right?
Yeah.
What will be this angle? Because it is negative, so you have to measure it in clockwise direction. So this angle is going to be negative 5 pi by 4. No doubt there?
Yeah, no doubt.
Okay, so these are simple questions and you can just try if you wish based on the same. I'm not interested in drawing this type of angle. The only thing you need to focus is positive and negative angle. Next, you already know about the complementary and supplementary angles.
Yes, I do.
Okay, so no need to tell you about that. Finding the complementary angle, finding the supplementary angle, these are going to be simple tasks. For the reference only, I'm just pasting this. I'm not interested in discussing any one of these. You are better there how to find the complementary, how to find the supplementary. Okay. Next, this is what I already told you. There are two measures in general. One is degree, one is radian. We just discussed about the radian when we talk about the central angle due to an arc. But because we already have measurement in degree also, so what is the equivalence there? So I already discussed with you that for the purpose of calculation, we will be considering that this 2 pi is going to be 360 degree. Am I right? And 1 pi is
Right.
going
Yeah.
to 180 degree. So 1 degree is going to be pi upon 180 radian and 1 radian is going to 180 upon pi. So sometime there will be a question to convert one into another there. There is a question to convert one into another. How you will convert? So whenever there is a angle theta degree and you will ask me to tell an angle in radian there. So what you will do, you will just multiply. You will just multiply theta into pi by 80 there. So whatever you will obtain, it is going to be in radian.
Hello?
Okay. Hello, am I audible
Oh,
to you?
sorry. Yeah, the meeting cut out for like.
Okay. So whenever there is an angle in degree and you need to give the answer in radian, so you will multiply by pi by 180 degree. And
Mhm.
whenever vice versa, if theta is given to you in terms of radian, radian is denoted by c sometime. So how you should obtain? Multiply it by 180 degree divided by pi. Whatever you get, that is going to be the answer in the degree there.
Okay.
So these
Yeah.
are the conversions you should keep in mind, and I hope I have told you about some of the conversions. Can you
Mhm.
just quickly go through the conversion for these three angles? Yes. Can you please help me? What is the corresponding value in radian? Like 135 degree, it is going to be 135 multiplied
Pi.
by pi by 180 degree.
Correct. Yeah.
Okay, degree will cancel out this degree actually. So 135, 180 both are divisible by 45. 45 threes are 135, 45 fours are 180. Pi is as it is there. So this is going to be the answer in radian. Okay,
Mhm.
like like negative 270 is there. Forget about negative. We are going to multiply by pi by 180 degree. Degree will cancel out this degree. Both have common factor. What is the common factor? 90 is the common factor
30.
there.
Oh yeah, 92.
90 maybe. So 93 is a 270 and 92 is a 180 multiplied by pi there. This is going to be the equivalent notation of angle. Any doubt there?
No.
And because it is negative, if I ask you to plot them, you will be plotting them clockwise.
Mhm.
Okay, just help me with one more thing. You need to convert radians into degree. You need to convert radians into degree. And how you're going to do this? Keep the
That'd
sign as
be
it is. Yes, please.
so it'd be negative pi over 2 times 180 over pi.
Perfectly okay. 180, you need to write degree divide by pi there. So pi will
Mhm.
cancel out this pi and 2 when divide 180, it is going to be
I
negative
mean 90.
90
Negative
degree.
90.
2 pi we already know it is going to be 360 degree. Can you please help me what is going to be 9 pi by 2?
9 pi by 2. It would be 9 pi over 2 times 180. So it'd be 9 times 90. So what? 810.
It is going to be 810 degree in total. You can just simplify and check the answers. Okay.
Okay.
Now, there is first we are going to have an application of radian measure and we are going to measure the arc length. So we know that theta, s and r, when theta is in radian given to you, this is the relation. So by chance, if a radius is given to you or known to you, and theta is given to you in radian, theta is given to you in radian, and if I ask you, tell
Mhm.
me what is going to be the arc length, what you will tell me, it is going to be r theta. Remember, this theta should be in radian.
Yeah.
If it is given in degree, you will first convert in radian and then after apply, and you will be able to find the arc length. Okay. Let us
Okay.
just have a question based on the same. It is the first application. Have a look at the question, please. A circle has a radius 4 inches. R is given to you. Find the length of the arc intercepted by the angle. Okay. So R is given to you 4 inches and theta is
Mhm.
going to be into 40 degree. I cannot use this to get the value of S, which is going to be R theta. I need the angle in radian only. So I will be multiplying
Do 40
this by
times pi
pi
over
by
180.
180 degree.
Mhm.
Now, 240, 180, there is a common factor 60 there. When you divide 64 are 240, am I right? And 63 is a
So
180.
yeah, so
So it
4
is 4
pi
by
over
3
3.
pi. So it is 4 into 4 by 3 pi. And what it should be?
16 over 3 pi.
Yes, 16 over 3 pi. Perfectly okay. You can leave the answer up to this point. And if you
Okay.
have if you are allowed to use the calculator, you can give the answer in decimal also approximately. I hope not an issue there.
Yeah.
Okay, the second application you will be having is based on the uh, linear angular speeds basically. So there are two types of speed you will be having. One is going to be the linear speed, one is going to be the angular speed.
Okay.
So just suppose a particle is moving along the circumference. A a particle is moving along the circumference. So basically, whatever the speed it will observe there, this is going to be our linear speed. Let me tell you once more. Consider a particle moving at a constant speed along
Mm-hmm.
circular arc. Okay, along the circular arc moving. So let me just use this statement like this. So initially at time t equals 0, it was here. And after some time t, it is at this point B, it was moving along this line. Am I right? What is the
Mm-hmm.
linear speed? Speed is going to be simply distance upon time. So distance is given to you like arc length. Time is t there. So this is going to be your linear speed. Any doubt?
No.
Okay. So initially, if you just look at the same circle, yes. Initially, just suppose you are at point A. Okay. This was the
Okay.
time t equals to 0 there. When you are moving, so there will be an angle while you are moving on this circular arc. So there is a central angle, and the central angle is also changing as you are moving on the circular arc. Am I right?
Yeah.
So there is a rate of change of angle also. This rate of change of angle is going to be your angular speed. This rate of change of angle while moving on the circular arc, the angle is going to change. This change is going to be your angular speed, and it is denoted by the central angle theta divided by t. So there are two types of speed you should know. Angular is going to be s over t. Sorry, not linear is going to be s over t. Angular is going to be theta over t.
Okay.
Okay, in both the cases, the speed is going to be constant. We are assuming this. Okay, there is a question related to this for you. Find linear speed. So there are three uh, needles, maybe. Am I right?
Mm-hmm.
One is basically measuring the hour. Second one measuring the minute. Third one is going to measure the seconds. This is what you already know that.
Yep.
Clear? Basically, if you consider this needle, so when it will revolve completely, it will create a circle. So if I'm moving along this line, something like this, so I will be moving on the arc. Okay, the moment should be in the anti-clockwise in general, but this time the movement is going to be in the clockwise direction, as you know how the needles will move, how the needles move in the in watch.
Mm-hmm.
So tell me what is going to be s. S is going to be 2 pi r. In 1 minute, in 1 minute, it will complete one revolution, which is going to be 2 pi r. Am I right?
Okay. Yeah.
What is the time taken? Time is going to be 1 minute. It is going to be 60 seconds for you. So what is going to be the linear speed?
So it'd be 2 pi r over 60 seconds.
2 pi r over 60 seconds. Perfectly okay. Because the numerator is going to be in terms of measurement centimeter, and denominator is second there. So the unit should be centimeter per second is going to be the unit. Now
Mm-hmm.
you just plug the values. R is going to be 10.2 2 there, centimeter,
Yeah.
and 60 is there. You can simplify whatever the simplification you will get, that will be the answer for you. Any doubt there?
Yeah. No.
So this is a question based on the linear speed basically. Let us just talk about another example where we will be discussing about the angular and the linear speed both. There is a figure associated with it. Let me just give you. There is Ferris wheel. Okay. Look at the wheel. I hope you must have seen this kind of wheel somewhere.
Yeah.
Okay. Most of the time,
Mm-hmm.
when there are festivals, so in parks, you may find these type of wheels there. Okay.
Yeah.
So just try to assume this length is given to be 50
So the
vertically. And
radius.
what can I assume? This is going to be a rectangle. I can tell you this is the same radius for you. So the
Mm-hmm.
radius is going to 50 for you.
Right.
So a Ferris, if a Ferris wheel with a 50 foot radius, it is foot there. Important, the notation of foot. Makes 1.5 revolution per minute. 1.5 revolution per minute. That means to say that what is going to be the S? S is going to be the complete revolution is 2 pi r and it is covering 1.5 in 60 seconds. Am I right?
Yeah.
So if I ask you what is going to be the linear speed,
It would be 3 pi r over 60 seconds.
2 pi r multiplied by 1.5 divided by 60 seconds. Am I right?
Yeah.
What was r there? It is
R
2
was
pi
50 feet.
50 there and 1.5 there divided by
Mm-hmm.
60. You get the point why I'm going to I multiplied by 1.5
Yeah.
because it is completing 1.5 revolution. This 2 pi r is one revolution for you. When you
Mm-hmm.
simplify this stuff, you will be getting whatever the calculation. It should be in feet per second. So I got the linear speed. This is the part B they were asking.
Okay. Yeah.
Okay. Next is I need part A there. Part A is find the angular speed of the wheel. So in theta is required. So if you talk about yes, what is going to be the theta? In 1.5 r, it is completing sorry in 60 seconds. In 60 seconds, it is completing 1.5 revolution. One revolution will give you angle 2 pi. 1.5 will give you 1.5 times 2 pi. This is the angle. This is going to the central angle for you. So omega represent
Okay.
angular speed there. It is the central angle. Divide by the time. Central angle is going to be 2 pi, that is 3 pi basically. Divide by the time is going to be 60 seconds for
60
you.
seconds.
Okay, so this angle is going to be, okay, they have
Pi
given the
over
answer in radian per minute. Okay, I have given the answer in feet per minute. I'm not interested there. Radian per second, this is will be my answer. Oh, they have asked you to give the answer in radian per minute. So in this case, I will be writing like 1 minute only.
Yeah.
Okay, so that is my mistake actually. I'm writing 1 minute. So it is going to be simply 3 pi there. 3 pi
Radians per minute.
radian per minute. Okay, there is no restriction for B part. You can assume degree, you can assume radian basically. Any doubt there?
Okay.
So I
No.
have not an issue there. Next, one more important issue you need to deal with is sometime there is a sector and we are concerned about the area of the sector, please. Okay, this is going to be a sector
Mm-hmm.
for you, and there is a arc length. You can consider S there. There is a central angle. What is the objective? What is going to be the area? What is going to be the area of this sector? So basically, I know that if the angle is completely 2 pi r, sorry, if the angle is going to be 2 pi, the complete revolution, the area is going to be 2 pi r. Sorry, area is going to be how much? Pi r square. Am I right? If the angle is going to be
Yeah.
complete, this is the angle basically, without any issue. So how should I make use of this to get the angle? So to get the radius, what I'm telling you, sorry, I'm concerned about the area. So this is the area corresponding to how much? This is the
For
area.
one. Yeah.
But
So
when you have a complete circle, A is going to be pi r square. Any doubt?
yeah. No.
Perfectly okay. So if you don't have any issue, intentionally I'm writing it like 2 pi upon 2 pi. Let me just write down somewhere else. So A is nothing but 2 pi over 2 pi r square. Okay. This is going to be the area for the complete circle. But now my circle, let me just denote it by AS there. But now my circle AS, it is only having this 2 pi is going to the center angle in the numerator, is only having central angle theta out of 2 pi. Okay, this
Okay.
numerator 2 pi is going to the central angle. For my case, like the sector, it is only having the central angle is going to be theta only. When you simplify, cancel out this pi with this pi, you will be having 1 by 2 theta r square. Remember, this theta should be in radian,
Okay. Yeah.
and that is all. Okay, so
Okay.
this is the formula given to you, the formula for the area of the sector.
Mm-hmm.
Remember, angle should always be in radian. Whenever we talk about radian, length, there's a question associated with it. Example number 8. Just look at the statement, please. A sprinkler on a golf course fairway is set to spray water over a distance of 70 feet, and rotates through an angle of 120 degree. Rotates through an angle of 120 degree. So you need to have spray of water. You need to spray the water, and the radius is going to be 70, and you can rotate up to 120 degree.
Mm-hmm.
So this is going to be a sector. I'm interested in the area of this sector. So how should you find the area? It is going to be 1 by 2 theta into r square. So in this case, theta is going to be 70 degree, which is 70 degree multiplied by pi by 180 degree. So if
Wait,
you
I thought,
allow,
wouldn't
yes,
theta
please.
be 120 degrees?
Oh, yes, yeah. So fair. Oh, yes, you are right. My bad. It is 120 degrees. Okay, 120 and 180, they have common factor like 60. So I can
60.
write like 2 by 3 pi. You are right.
Yeah.
So it is going to be 2 by 3 pi into radius is going to be 70. So I
70
mixed
squared.
these values. Sorry for this. Simplify whatever the answer. This is going to be your answer. What should the unit? Unit is square feet.
Yeah.
This is going to be the unit. No doubts?
No, that's.
Okay, so you have exercise 4.1 based on the same. I'm leaving this exercise for you for the timing. First, you try them, and then after we will be discussing this exercise maybe in the next class if required. I don't think it will be required. We have discussed all the topics in detail basically up to this point. Okay,
Mm-hmm. Okay.
so next is going to be next. This is going to be something very important, and it is going to be the core of trigonometry, whatever you are going to discuss here. The unit circle. In section number 4.2, whenever I talk about a circle, by default it is unit circle until I mention the radius to you.
Okay.
So You know about the equation of the circle. It is going to be x square plus y square equals 1. That means I'm talking about a circle with the center at 0, 0 and radius 1 there. Do you agree?
Mm-hmm.
Okay, consider this figure and how we are going to make use of this. So it is a unit circle and there are 4 points I'm mentioning A, B, C and D there. What is the angle at A? The angle at A is going to be 0 radian. Angle at B is going to be theta equals pi by 2 radian. Angle at C is going to be pi
Pi.
radian. This is going to be 3
3 pi
pi
over
by
2.
2 radian. And when you go back, it is going to be 2 pi radian.
2 pi.
Any doubt there? Just suppose there is a point P there with the
Okay.
coordinates A and B. And I'm joining this P with this with the center. This is O there. The central angle is going to be how much? Theta. I'm measuring it along the anti-clockwise direction. And in order, I need the value of A and B actually. So let me just draw a perpendicular to the axis there. Let me just call it this as Q. Q. Let me just use it Q there. So O is there, Q is it is Q basically. This is P for you. So this is going to be your triangle. You need to focus on the in the triangle OPQ. What is A there? A is going to be how much? It is the X value. It will be your OQ. What is B? B is going to be the perpendicular value. It is going to be PQ. And because it is perpendicular, I told you this is going to be 90 degree. Am I right? This angle is going to be 90
Yeah.
degree without any issue. Please try to help me using the basic trigonometry. What is going to be cos theta? It is going to be adjacent divided by hypotenuse. Adjacent is OQ. Hypotenuse is going to be OP. OP is going to be 1 because it is a unit circle. OQ is
Mm-hmm.
A upon 1, that is simply A. Any doubt?
No.
Similarly, if I ask you, tell me what is going to be sine theta. Remember, theta is the
It'd be
central
P.
angle.
Yeah, it'd be PQ over OP.
Perfectly okay, and it is going to be B. So the important observation you should draw up to this point is this point P have another notation. In terms of the central angle, one is cos theta, another is going to be sine theta. Do
Mm-hmm.
you agree?
Yeah.
Perfectly okay. Okay. So let me just take you to the another. Okay. I left one statement basically. Let me just show you what I told you. Give me a second. No, sorry. I have given you something that is ahead of this section basically. No issues. So I hope if any point P is there, I can represent this with cos theta, sin theta. First coordinate is cos theta, second coordinate is going to be sin theta. I told you about the angles only. So this will come maybe in the later section. Okay, unit circle.
Okay.
Let me just go
Yeah.
back with the statement there. Now try to consider that just suppose there is an angle given to you, but the angle is given in terms of the radian basically. Check. Just suppose there is an angle given to you and the angle given to you in terms of radian there. Okay,
Mm-hmm.
just suppose the angle is given to you in positive direction. This is t bigger than 0. So what you will do, you will just consider this t to be on the circle. T is representing angle, remember this time. When it is positive, you will be having positive direction of measurement. And when t is negative, you will be having negative direction of measurement. Any doubt there?
Okay. No.
Okay, so you just this is going to vertical. You just try to just match with the point. So you starting from A, you are ending up to B. This is going to be your measurement in uh, radian. Remember, positive direction will be anti-clockwise, negative direction will be clockwise, like you already know them. Okay, trigonometry functions you already know. I'm not interested there. What I'm interested in the identities. So based on that, let us talk about the identities. What I told you.
Hello?
Yes, am I audible to you?
Yeah. The
Okay.
meeting keeps cutting out.
What I told you. Recently, if you can focus, if you are able to find this angle theta there and the radian angle is t there, what was x? X was cos
Well,
theta. Am I right?
yeah.
What is theta basically? Theta is now your t in radian. So you forget about t, you will write it like cos t. What is your y?
Okay.
Y is your,
Sine theta.
you will consider this as sine t there. So please try to help me. For this question, if I ask you what is my y there, it is sine t. You told me, help me. What is x there? X is your cos t.
Cos.
If I ask you what is your tan t, tan is going to be the ratio of sine and cos. Sine t over
Yeah.
cos t. So you will tell me it is going to be over how much? X over y. And rest of the trigonometric expression can be obtained because those are going to be the reciprocal of these trigonometric expressions. Am I right?
Yes.
So corresponding to any angle t, corresponding to any angle t, t is a real number basically. You will be having these, you will be having a point on the unit circle. Remember the statement. For any angle
Okay.
t, you will be having a point xy on the unit circle. And what is going to be the relation? Sine t is going to be y, cos t is going to be x, tan t you already know. Cosec t is going to be the reciprocal of sine t. Cos t is going to be the reciprocal of secant t, and tan t is going to be the reciprocal of cot t. Do you agree?
Yes.
No issues are there.
Mm-mm.
So now we have got for any t. Let us just try to find out the value for some particular angles. Let us just try to find out the value for some particular angles. For this particular situation, let me just show you something. Yes. And I'll tell you about this figure. What is given to you, it is given that it is a circle there, and what you can observe, this angle is going to be the central angle in terms of radian. The first quadrant is of length pi by 2. It should be the half of pi by 2, that is pi by 4. Any
Okay,
doubt?
yeah. No.
So if this is the point P there, the value of cos pi by 4 is given to you, and the second value is going to be sine pi by 4. The question is, how can I get these values? The answer is simple. You have x square plus y square equals to 1. This is the equation of circle. And if you consider
Mm-hmm.
this line in usual way can be written as y equals x there. Whatever be the points of intersection of these two, it will give you two values. One is p, one is going to be q. Let me just try to solve this. Just substitute or plug y equals to x there. So you will be having x square plus x square equals 1 there. After substituting the value, it is 2x
Mm-hmm.
square is going to be 1 there. X square is going to be 1 by 2. And from here, the value of x is going to be with the positive negative sign 1 over square root of 2. Let me just multiply it by square root of 2 in the numerator and denominator. The value of x is going to be how much? Plus minus. Help me.
1 over
Square root
pi
of
2.
2. Okay. Because x is equals to y, the
Oh,
same value is going
yeah.
to be y there. Okay. And the coordinate of p with the it was given to you like a b. So because in it is in the first quadrant, you will be having positive values only. So it square root of 2 is square root of 2 by 2. And coordinate of q, if you ask me, because it is in the third quadrant. And third quadrant, both are going to be negative. So I will be using negative root 2 by 2 and root 2 by 2. Do you agree?
Mm-hmm. Yes.
Okay. So if you know the correct line, and then you will be able to get the answers. And because uh, P is corresponding to the angle theta equals pi by 4 radian there. I can tell you my cos pi by 4 is the first value root 2 by 2 and sine pi by 4 is same. Am I right?
Mm-hmm.
Can you please help me one more step? What will be this angle?
Theta is going to be
See, one
pi,
straight
so
line is
pi
pi there.
over.
It is pi plus pi by 4. It is
Oh,
pi plus pi by 4. Am I right?
okay.
See,
Yeah.
uh, when you started the angles, theta was 0 there. At this point, theta was pi. Am I right? And this is going to pi by 4
Yes.
only. So if I ask you, tell me what is the value of cos pi plus pi by 4. You are going to help me with negative square root of 2 by 2. Any doubt there?
No.
And similarly, sine pi plus pi by 4 is going to be in that same. So we will be continuing these type of situations. My request to you will be, you need to try to find out, try to mark the points with the angle in this circle. Okay, this is my request to you. I just told you what is going to be square root of 2 with the angle. I can help you. This is going to be pi by 6 there. And this is going to be pi by 3, corresponding to pi by 3. You need to mark the angle. So this is for that today. Okay, I'll see you in the next class.
Okay.
Thank you. Bye bye. I'll share the notes with
Okay.
you.
Mhm.